is a video about using or creating a BlinkyPi project that will blink a single LED on your Raspberry Pi 3 using Netbeans and in this case Java. Now I've shown you a video before that shows how to do it in C++. In order for this to work, we have to set up our Netbeans project similar to a previous video that I showed you how to connect remotely to your Raspberry Pi. I'm not going to go through all that process here because I've already got a video out there, so I would recommend that you go back and review that video in order to be able to connect your PC or Mac or whatever to your remotely to your Raspberry Pi. So first thing we need to do is, in order to do this with Java, we're going to use a library called Pi4j. So if we go to look for Pi4j on the web, we will come up with their website. And here's the Pi4j project. And what we're going to do is we're going to click on download so that we can start to download the library itself. In our case, what we're going to be looking for is a release build, and we're going to download the compressed archive. Now I'm using a Windows 10 machine here, and I'm going to assume that you're using that or maybe a Mac. You could do the same thing with a Linux as well, but if you're using a Linux you might want to use a Debian package instead of the zip package. But in this case we're going to be using a Windows 10 machine, and so I'm going to download that zip. That zip has been downloaded, so let's take a look at that. Looks like it's just about done. Okay, and so let's show it in the folder. So here we have this. I'm going to just take this and drop it on my desktop. So let's just do that real quick. Let's drop it on the desktop, and we'll close out that, and we'll minimize, close this out, and we'll minimize that for the moment. So here's Pi4j. What we want to do is we want to, if you have 7-zip or maybe you're using WinZip or whatever your archive tool is, we're going to extract it, and we're going to extract it to this particular folder. So now we have an uncompressed folder of the Pi4j. In order to set this up, what you want to do then is you want to place it somewhere where you're going to use it as a library. In my case, and you may want to do the same thing too, because I think this is probably the easiest way, is go to Program Files, and I have a folder set up as Java, and in that folder I have my JDK. Well, I also just take this folder and move it into here. Now I've already done this previously, so I'm not going to redo it, but you see here that I have the Pi4j library in the Java folder. So that would be what I would recommend. We'll just clean this up because I don't need that anymore. And we'll go ahead and minimize that. So now that we have that, we need to make sure that we have this set up in our project. So if I bring Netbeans up, we're going to create a BlinkyPi project. So let's go ahead and we'll take a new project. We're going to go Java with and we're going to go Java application. So that's a simple, straightforward defaults. And we're going to call this one BlinkyPi. Okay, so we take that, take all the defaults, and we have us a small project. Now, first thing we need to do is we need to make sure that we're able to connect remotely. So the first thing that we want to do is we want to go up here to the project, get properties, and we want to make sure that the sources are set for the JDK on the Raspberry Pi. In my case, it's going to be JDK 11, and that will allow us to come down here to the Run and select the Remote Pi platform for our Raspberry Pi. And now, like I said, we had created this in a previous video, so if you don't know how to do this, go back and review that video, and it will give you an opportunity to select that. It's going to want you to put in a configuration name, so we'll just give it Remote Pi for a configuration. and that will allow us to connect directly to the Pi. First thing we want to do is make sure that that connection is working well. So let's go ahead and put in a little piece of code here to do that testing. We'll just do a print line. Print line, and we'll say, using our same command that we've used before, your OS is, give it a space, close it out, and let's do another command here. Okay, and that should give us the OS that we're operating on. And if we're operating correctly and we're connected correctly, we should get Linux as the operating system. So let's take a look, see if it connects. Looks like it is, and it reports that our OS is Linux. So it looks like indeed we are connected now to our Raspberry Pi. So the next step is to make sure that our Pi4J libraries are connecting or are visible to our Netbeans IDE. So what we want to do is we want to go up here to the properties again. Well, before we do that, let's do this. Okay, so we'll go to libraries. As you can see, the libraries on our project is set to the default JDK 14. Well, we're going to need to add P4IJ or Pi4J to this library setup. So let's go and we click Add Library. Now, in my particular case, I've already created a Pi4J-core library, but just to show you how it works, we're going to go ahead and we're going to click the Create button. And we'll add something to the effect of my library, and then you click OK. And that's going to bring you into the next menu, which is going to look like this. Oops, actually I need to add that to it, so let's go ahead and do that real quick. I'm going to go ahead and add my library to it. Now, when you did the Create button, you would get this particular menu, the Edit menu. Okay. Now you're going to have to add a few things. So, wherever you located your Pi4J core libraries, then we're going to have to click on Add the jar file. So, if we go to that location, in my case, if you remember correctly, or if you remember, it was all the way up the top. So we go to Program Files, Java, and here's Pi4J. So if we delve into there a little bit deeper, now we're at the library files. Okay, so let's take that. And for our class path, we want to add the Pi4J core jar to that. So we select that and we say Add jar file. And as you can see here, I've already added it, and you should have something similar to this with your class path. The next thing you want to do is you want to click the Sources tab. And in this case, you're going to click it again, click the Add jar file folder again, and you're going to come back in here. And we're going to go back into Java, back into the library folder, and you'll notice that there is a Pi4K sources jar file. You'll use that for the sources. Then you're going to click the JavaDoc tab. Oops, and in this case, you're going to do Pi4J-core-javadoc.jar. And that gives you all three references that you need for that particular library. And then if you click OK, you'll notice that you now have your Pi4J core library set up. So we have to go back in and do a couple of checks here real quick. Let's go back to the project, Just click on Properties, and let's check that the library has been listed now. And you notice here that it has been listed, and it's PI4J-core as a library. So our library is now created and it's been added. And we should be good at this point to be able to run a PI4J program. So let's just take another quick run at that to make sure everything's still working, even though we added the library, and indeed it looks like it's good. So now, first thing you want to do with this BlinkyPi and PI4J is you want to add in a new class. So we're going to add a class. Let's go to Source Packages. We have the BlinkyPi, which gives us our static main function here, but we want to add another class. So let's just add another one. And we're going to call this one Controller. And we finish out on that one. So the controller is actually going to be where most of the magic's going to happen. The BlinkyPi.java is simply just starting up and instantiating the objects. So let's add a little bit of code here. First thing you have to do is make sure that your imports are working correctly. So if I bring something up here, I'm going to do a little cut and pasting so we don't have to do a lot of typing here. And let's put these imports in the code here. Okay, so you should have everything you need here. Now, Netbeans with this new IDE gives you all kinds of warnings, but that's okay. It's just saying that it's unused. As long as it's not red, it's not really a big deal. So now, the other thing is, in order to get started, we need to be able to create a Gpio controller. That's one of the main things that PI4J uses to access pins. So let's put that little piece of code in there. And you'll notice that a couple of those imports now are used. So we have, first thing that we're doing here, of course, is as this class is instantiated, is we're going to create this Gpio controller. And the next thing that we want to do is we want to be able to shut this controller down. So one of the first functions that or methods we're going to add is going to be a kill switch. So let's add that. And all this method is responsible for is basically shutting down the Gpio controller. So after that, we want to set up a pin. Now, here's where it gets a little bit tricky. In PI4J, they utilize the wiring pi numbering system. Okay, so just for information, if you want to find out how your particular Raspberry Pi is wired up, let's just take a quick look here. This is Putty, and I'm connected to my Raspberry Pi, and I want to find out exactly how it's wired up. Now remember too that PI4J library needs to also be added to your Raspberry Pi. So what I've shown you is adding it to your Windows PC so that you can compile it on Netbeans. You also need to have PI4J installed on your Raspberry Pi. So make sure you go back and you can go to the PI4J website that I just showed you, and you can get information on how to install it on your particular version of Linux, depending on what you're running on your Raspberry Pi. But it's a fairly straightforward process because you're able to use the basic, the Debian download kind of commands. apt-get is probably the preferred way to do it. Okay, so let's just, this is a simple command that you can instantiate on your Raspberry Pi. So Gpio read all, and let's see what the results are. Okay, so if you look at that, you see that it gives you basically all the pinouts for your particular board, and in my case mine's a Pi 3B. It's not a 3B plus, it's a 3B. So here's the header in the middle where it says physical. You notice that there are 1 to 40 pins. On my particular board there's a 40 pin header, and depending on what your configuration is, it will show your physical pins, and then also it will map it to the BCM GPIOs, which is what I showed you in the C++ when we did the code for that. They utilize the GPIO, the BCM GPIOs, which are real mappings to physical signals on the Broadcom chip. In the case of the Raspberry Pi 3, that's a BCM 2837 chip, and it's different depending on which Raspberry Pi you're using. Also though, and those BCM numbering points are actually on the far left and far right of this grid that you see here, and coming in one column from those you'll see the WPi designation. Those are the port designations for WPi, which are generic and defined specifically for the code for wiring Pi code. It's not related to the BCM numbers. As you can tell, they're different. And the reason they do that is for portability across the board. Now, one way to get this particular file, if you want to be able to utilize it, is to do Gpio read all, and then just use this little arrow command, and let's put it into a text file. So now that particular file is in a text file. To see it, you can utilize VNC Viewer. If you don't know how to install VNC Viewer, there's a lot of videos out there that will show you how to do that, so I recommend that you definitely have VNC Viewer and connected to your Raspberry Pi so that you can utilize a lot of the tools. So let's bring this up. I have my Raspberry Pi already connected, so if I go to the base home Pi folder, I should see something that says pinout.txt. And if let's see, on the PuTTY, did I call it that? Yes, I did. I called it pinout.txt. So let's click on that, and there you go. Using their the mouse pad tool on Raspbian, you can see there's the matrix and it's clearly displayed. Now what I did for simplicity is I took that file and I moved it over to my Windows machine. Okay, so how does that happen? Well, let's minimize this out. I utilize a tool called Filezilla. It's basically an FTP client. If you're using Windows, I'd recommend this is probably an easy way to get access to your files on your Raspberry Pi. So here I am in Windows, and I'm going to access the Raspberry Pi. I've already set this up for connection, and it should, fingers crossed, everything work right. Just going to ask me for my password, and there you see it. So now it's populated. There's my pinout text file that I originally had, and I can basically, with this one, you can just grab this, you can drag it over and just drop it onto your Windows panel that's over here. I'm not going to do that because I've already got a copy of it over there, but that's an easy way to just drag and drop your files off your Raspberry Pi onto your Windows machine. So if you haven't used Filezilla, I recommend checking that one out. Okay, so now we have our text file over there, and let's take a look at it. I've actually ported that over to a PowerPoint slide, and let's just take a quick gander at it in a larger format here. Okay, so Here's the Broadcom designation pins on the far left and far right. Come in one column, far left, far right is the WPI designations, and those are the designations that we will use for actually coding in Pi4J. Now, we're going to use designation pin 0, as you can see, GPIO 0, and we're going to, which correlates to physical pin number 11. Okay. Now, in the previous video that I did with the BlinkyPi, where I showed you how to wire up the LED and the resistor to the Raspberry Pi, this is exactly the same pin out. So we're going to utilize pins 9 and 11, which is 9 is the ground pin and 11 is the signal pin, and we're going to hook it up on the motherboard, on the the breadboard, exactly the same way as that video was. So if you don't know how to do that hookup, go back and review that video, and that will help you get your LED hooked up to your Raspberry Pi. Okay, so enough of that. Basically, that gives you a really nice way to go in and check your specific boards, because this printout is going to be specific to your applicant, to your piece of hardware, and it gives you a really good picture of where what you're working with here. Okay, now that we can actually provision a pin and actually get it set up as a output for the LED itself. So we'll just create a output pin function. And we don't need anything specific in there, just a placeholder. And let's go ahead and put in, the first thing to do is to put in some code to create an output pin using the provisioning tool that Pi4J provides. So let's add that in. And in this case here, we're creating a Gpio digital output, and we're calling that My LED, and we're using the Gpio provision tool. And you'll notice here that I've got this set to Gpio pin 0, or Gpio 0, signal 0. And that is because that matches up to our physical pin 11 that we had previously used in the C++ example, so we're matching that here in the Java. The next thing we want to do is we want to ensure that the output of that LED is going to be low, so we are going to restate that using some of the functions of it, and here you'll see that that forces the LED to be low. Okay, so now that we have it in a low state, we want to be able to toggle this thing on and off so that the LED will flash. For this specific example, I'm going to set it up in a loop where it only flashes 10 times. That way the program will exit automatically and you'll have control back to your PC. So let's set this up with a for loop. And that's pretty straightforward. It's a basic for loop. Okay, so you'll see here that it's set up with a basic for loop. It's going to count 10 times. And so what's happening here? Okay, well, there is a function in Pi4J that allows you to toggle a pin high-low. So rather than having, in the case that we did just previously where we specified it to be low, we're actually just going to toggle it from high to low. So if you look in the try statement, we have a sleep statement that says sleep for 500 milliseconds. Then, using My LED, let's toggle that value from low to high. Then we're going to sleep another 500 milliseconds, and then we're going to toggle it from high to low. And we keep doing that over and over, alternating. And it will do that 10 times before it exits, and then you'll see the program quit. Okay, so let's see if indeed everything there. Well, let's go back to BlinkyPi. So we have to actually create a function. Don't need this particular statement anymore, so I'm going to comment that out. And let's instantiate an object here. We're going to do so we provisioned a controller. And we're going to say control create a pin, an output pin. And then we're going to, after we've done that and it's run itself 10 times, it will quit, and then we're going to do the kill switch to make sure that we terminate the Gpio controller. And that should give us a blinking LED. So let's check to see if that's going to work. We're connecting to the Pi. Looks like it's flashing. The LED is flashing, so we should get 10 flashes. And then we should see a termination of the program. And indeed it did, it terminated. So that works, and that is basically BlinkyPi using Java. So I hope you guys enjoyed that, and if you have anything that I've brought up in previous videos that you would like to see something done, just because you're not quite sure how that whole process worked, put it in a comment, and I will try to come up with a subsequent video that may address that issue. So I hope you guys enjoyed that, and we'll talk to you all next time. So I'm not sure what the next video is going to be, but yeah, I'm sure it'll be something to do with the Raspberry Pi, and I was thinking about doing maybe something to do with motors. We'll see how that goes. We'll talk to you all later. Bye.